Hi students, welcome back to myclass.com. In this video, we are discussing about expression evaluation and conversion, stack applications. We are doing arithmetic expression evaluation and conversion by using stack in a programming language. Okay. So before going to that, we are discussing what is arithmetic expression, what are the three main types of arithmetic expressions. So let's start. An arithmetic expression can be written in three different but equivalent notations. That is, without changing the essence or output of an expression, we can express this arithmetic expression in three different ways. These are infix notation, prefix notation and postfix notation. The other name of prefix notation is Polish notation. Actually, the postfix and prefix is opposite to each other. So we can say that the postfix notation is reverse Polish notation. The normal arithmetic, we all know mathematical expressions like 2 plus 3, 2 divided by 5, like that. These are our arithmetic expressions. So infix notation is we can express like very simple, very normal, that is a plus b. This is an example of infix notation. We can say that 2 plus 3. 2 plus 3 equal to 5. So this infix notation we can also express in prefix style also and the postfix style also. Prefix notation or Polish notation is like always the operator is first. Prefix. We are considering operator first, then we are writing operands. After an operator, two operands will be there. This two operands is for addition purpose. So we can write like this 2, 3. So here also the answer is 5 because this the meaning is 2 plus 3. That is the Polish notation. Now the reverse Polish notation, that is the postfix notation. Operand is first, then only we are writing the operator. The meaning is A plus B itself. So we can write like this 2 plus 3. So the answer is also 5. These are the three different arithmetic expression notations: infix notation, prefix or Polish notation, postfix or reverse Polish notation. Clear? Now, for an arithmetic expression, there are simple arithmetic expression and complex arithmetic expressions. And simple arithmetic expression, only one operator and the two operands. There is a chance of containing an arithmetic expression with more than one operator and lots of operands like A plus B multiplied by C subtract by D, like that. This is also an arithmetic expression. Let's consider when an operand is in between two different operators. Let's consider B. B is in between plus and multiplication, addition and multiplication. In such cases, which operator will take the operand first is decided by the precedence of an operator over others. Here, addition is there and multiplication is there. Actually, addition has the more precedence than addition. Multiplication has the more precedence than addition. So, we want to calculate this first. Then only we are going to the addition statement. So, for evaluating, we are doing like this. We are multiplying B and C, then the result is adding to our eval. That is the precedence case. Now, the another case is associativity. Associativity means the rule where operators with the same precedence appears in an expression. If, for example, A plus B minus C is the A plus B minus C. Here, we all know that the addition and subtraction have the same precedence and also the multiplication and division has the same precedence. In such cases, like if in some expressions we have more than one operator with the same precedence, then there is a rule that we want to evaluate the expression in such a manner that there is a rule to evaluate the expression, that is maybe sometimes it is left associativity and sometimes it is right associatives. The addition and subtraction is left associativity. Has the left associativity, that is we want to calculate A plus B first and we are then subtracted by C. Okay, and in such simple expression there is no change of value when we are doing the subtraction first and then we can do the addition also. But when we are considering very complex expression, we want to follow this associativity rule also. Okay, so that is the associativity. Now this is the precedence and associativity table, and this the operator, exponential operator, has the very highest precedence with right associative. This operator is right associative. When we are considering an expression with the exponential term, we are calculating in the right way. Okay, from the right side. And in multiplication and division has the second highest. Multiplication and division have the second highest precedence, and it is also left associative, and addition and subtraction is very lowest and it is also left associative. Only the exponential term has the right associativity rule. Okay, so that is all about the precedence and associativity table. When we are evaluating an infix or prefix or postfix expression, and also we are converting one to infix to prefix like that, with the help of stack, we are considering precedence and associativity for evaluating such things. Okay. As an introduction, application of stack, expression evaluation and conversion is the most one important application of stack. The list of expression conversion and evaluation includes, we can perform infix to prefix conversion by using stack, also infix to postfix, prefix to infix, prefix to postfix, postfix to infix, postfix to prefix. We can also evaluate the postfix expression, also prefix expression, by using stack. These all are the main applications of stack related to expression evaluation and conversion. So let's discuss first infix to postfix conversion. This is the algorithm for infix to postfix conversion. The algorithm contains lots of explanations, but it is very easy when we are explaining this is with an example. First, I am just reading this algorithm. So listen. First step is, if the scanned character is an operand, put it into the postfix expression. When we are scanned from left to right, if it is an operand, we are pushing that into postfix expression. One more thing is, we are using a stack, operator stack. We are pushing and popping operators to and from the stack. If the scanned character is an operator and operator stack is empty, then no problem, push operator into operator stack. Step 3 is little bit confusing but easy. If the operator stack is not empty, our scanned character is an operator, and when we are looking to the operator stack, it is not empty also, then there is some possibilities. We are considering that possibilities and doing push or pop operation. 5 conditions are the, if the precedence of scanned operator, we are scanning one operator from the infix expression, that operator is greater than the topmost operator of the operator stack, push that operator into the operator stack. If it is greater than, our scanned operator is greater than, push into the stack. If the scanned operator is less than the topmost operator's precedence when we are considering, then pop the operators from the operator stack until we find a low precedence operator than the scanned character. Now only just focused on this concept. Okay. If the precedence of the scanned operator is equal, then check the associativity of that operator. If the associativity is left to right, then pop that operator from the stack until we find a low precedence operator. If the associativity is right to left, then simply put into the stack. The last thing is, if the scanned character is an opening round bracket like this, push it into the operator stack. If the scanned character is closing round bracket like this, pop out operators from operator stack until we find an opening bracket. Repeat 1, 2, 3 till expression has character. After all scanning of all the characters, step 4 is now pop out. Maybe some operators are remaining in the stack. Now pop out all the remaining operators from the operator stack and push into the postfix expression. Exit. That is the algorithm steps, just read one time and we are going to explain the concept with an example. Infix expression. Our infix expression is a plus opening bracket b star c plus d closing the bracket divided by e. We are scanning from left to right. Okay. So first we are considering A. A is an operand. We are just adding this into the postfix expression. Clear? Plus is the operator and we are pushing that operator into the stack without considering anything because stack is empty this case. Okay. Now we are scanning opening bracket. So opening bracket, when we are scanning opening bracket, we are just push that opening bracket into the stack, operator stack. So now the postfix expression is still contains A itself, A only. Now we are scanning an operand B. If the scanned character is an operand, we are pushing that into our postfix expression. Now the postfix expression contains A, B. Stack contains plus an opening bracket. It is star multiplication. If a scanned character is an operator, the stack topmost element contains the operator, then we are checking lots of condition. If it is not an operator, no need to worry. We are pushing that operator into the stack. Now the postfix expression is AB. Now our scanned character is C, adding C into the postfix expression. Now another operator came plus. When we are scanning the plus, our stack is like this, plus opening bracket stack. If the topmost element of the stack is an operator, then we want to compare the precedence of that two operator. Our scanned character is an operator and our topmost element is also an operator. We want to check the precedence. Okay. If the topmost elements has the higher precedence, then we can't put plus into this position because this has the higher precedence and this is the lower precedence. It is not a fair thing that a lower precedence operator is lying above the higher precedence operator. It is not possible. So we are popping the star into the postfix expression. We are popping the star into the postfix expression. Then we are adding addition to this stack. This operation will continue until we are reached the topmost element as lower precedence operator. So after popping the star, the opening bracket came. So at that time we are pushing this addition into the stack. Okay, plus operator has less precedence than star, so pop star and add to the expression string. Now the D came. It is an operand, so we are adding this into the postfix expression. Now a closing bracket came. When a closing bracket encountered, we are popping all the operators until we reaches a opening bracket. So this is a closing bracket, so we are popping all the operators until an opening bracket. So we are popping this addition to the postfix expression and we are ignoring this bracket. So now the stack only contains the plus. We are reached the division operator. The division operator has the highest precedence than plus. It is okay to lie above a lower precedence operator. Division has the highest precedence and the topmost elements contain a lower precedence operator. Then it is okay to push into the stack. So we are pushing division into this. Our E came. E is an operand, so we are adding E into the postfix expression. Now we have reached the end of the infix expression. So after that we are checking is the stack contains another element or not. Yes, stack contains two more operators. So we are popping all the operator from the stack. We are popping first division and adding into the postfix expression. Then we are popping addition and adding into the postfix expression. So this is the equivalent postfix expression for our infix expression. Okay. Hope it is clear now. So this is the example for an infix to postfix conversion. Our infix expression is A plus B star C divided by D subtraction F plus A exponential E. So we are scanning from left to right. First we are scanning A. A is an operand, so we are adding A into our postfix expression. Now we are scanning plus. plus is an operator. Operators, if the stack is empty, no need to worry. We are pushing that plus into our stack. Now our stack containing one element. Again, we are scanning an operand. So operand, when we are scanning operand, we are adding that operand to our postfix expression. Now we have reached here. There is a star multiplication operator. If the topmost element of the stack is an operator and our scanned character is also an operator, we want to check the precedence. The star has the higher precedence than addition. So it is okay to lie above a lower precedence operator because star has the higher precedence, so it is okay. So we are pushing star into our stack. Now another operand encountered. We are adding that operand into our postfix expression. Now we are scanning the division operator. If the division operator, the scanned character is an operator and our topmost element of the stack is also an operator, we are checking the precedence. Star and division have this equal precedence. So we want to pop all the operators until we have reached a low precedence operator in the stack. So we are popping star from here and we are adding into the postfix expression. Now we are again checking the topmost element. So we have popped star. Now we reached the plus operators. Plus has the lowest precedence, so no need to pop now. So we are pushing division into here. We have already popped the multiplication. Now adding the division operator to the stack. Now we have reached here D. D is an operand, so adding into the postfix expression. Now there is a operator and here also an operator is there, so we are checking the precedence. Our subtraction is precedence is less than the division, so it is not fair to lying above a higher precedence operator. So we are popping this division into postfix expression. We have popped the division and we are repeating all the steps until we have reached a low precedence operator. Okay, so we have popped the division. So we have already popped division and now we are checking plus. Plus also has the same precedence with the subtraction. So we want to pop addition also. So we are popping this addition also and adding into our postfix expression. Clear? So we have popped the division and the addition from the stack and we want to adding the subtraction into this operator stack. Okay, we have popped this too and we are added into the postfix expression. Now we are adding the subtraction into our operator stack. So now the stack contains subtraction. Now encountered F. F is an operand. So we are adding into our postfix expression. Now there is a operator came. Now we are here. Okay, this has the same precedence. So we are popping plus and minus has the same precedence. So we are popping minus from the stack and adding plus into this. Okay, so now stack contains addition. Now there is an operand A. A is an operand, so adding into postfix expression. Now there is an exponential E. Exponential, so we are adding exponential into our operator stack. Now there is an operand, we are adding this operand into postfix expression. So this is the end of our infix expression. So after that we are checking our operator stack is empty or not. If it is not empty, we are popping all the elements to postfix expression. So we are popping first this one and now this one. So this is our postfix expression ABC star D divided by plus F subtraction AE raised to addition plus. Okay, so next is infix to prefix conversion. Our algorithm contains 7 steps. The first step is checking lots of conditions that we are discussing here. Okay, so first our step was reverse the infix expression. That is very important when we will get a infix expression. Let's see, this is our infix expression. So we want to reverse it like this. C star, this closing bracket first B plus A opening bracket. That is very important. Okay, this is a closing bracket and this is our opening bracket. We are scanning from left to right. We are reversing the infix expression, then scanning from left to right. Scan the expression from left to right. Whenever the operand arrive, print them. There is an operand, we want to print it into our output. If the operator arrives and the stack is found to be empty, then the stack is nothing is there in the stack, then we want to just push that operator. No need to check any condition. But if the operator arrives and the stack is found to be non-empty, then we want to check lots of things. That is this one. If the incoming operator has higher precedence than the top of the stack, then push it into the stack. It has the same precedence, then also we are pushing into our stack. We are not popping. Only in the lower precedence case, the top of the stack has the lower precedence when compared to incoming operator. If the incoming operator has lower precedence than the top of the stack, pop and print the top of the stack till it finds an operator of a lower precedence for same precedence. We are continuing the same step until we want to reach a lower precedence or same precedence operator at the top of the stack. One more thing is, special thing is, if the incoming character is an operator has the same precedence with the top of the stack. If it is a same precedence, we are pushing into stack, but here when the incoming operator is exponential with the very higher precedence, then pop the top of the stack till the condition is true. Till the condition is true with the same precedence or higher precedence, we are popping. If the condition is not true, if it is the same precedence, we are popping. Otherwise, the condition is not true, push this exponential operator into our stack. If the operator is a closing bracket, then push to the stack. If the operator is an opening bracket, then pop all the operators from the stack till it finds a closing bracket. Okay. If the top of the stack is a closing bracket, then if the character is an incoming character is an operator, then push the operator into the stack. That is the all condition we want to check when an operator arrives and the stack is non-empty. Now let's discuss this algorithm with an example. Our infix expression is k plus l subtraction m star n plus opening bracket o raised to p closing bracket star w division u division v star t plus q. Little bit longer, but with the example we can check all the conditions in the algorithm. Now first step is reverse our infix expression q plus t star v division u division w star closing bracket p raised to o opening bracket plus n star m subtraction l plus k. This is our input. This is we are using as the input. We are scanning this expression from left to right. When we are scanning, if an operand came, put into our output expression. Okay, add into our output expression. If it is an operator and the stack is empty, no need to worry. We are just pushing that operator into our stack. If it is an operand, we are adding this into our output expression. If it is next is a star is an operator, and when we are checking the stack is non-empty, but star has the higher precedence when compared to our addition, then we are just pushing that star into our stack. Now there is an operand came, that is v. Now there is another operator division, that is the same precedence with our star. When it is the same precedence condition, we are pushing this operator into our stack. Now there is another operand, that is u. Now there is another division that is same with the same precedence condition. We are pushing that into our stack. Another is an operand W we are adding into our output expression. Now there is a star. Star also has the same precedence with our top of the stack division. We are pushing into our stack. Now there is a closing bracket. When a closing bracket came, we are just push into our stack. Now there is another operand P. Next is an operator exponential. When exponential came, we want to check lots of condition, but in this particular case there is only a closing bracket, then no need to worry, we are just pushing that operator into our stack. Now another thing came, O, we are adding this into our expression, output expression. Now there is a opening bracket came. When opening bracket came, we want to pop all the elements till a closing bracket finds in the stack. So there is only one operator in between this. So we are popping this exponential and we are ignoring this also. So the stack is not containing this two now. Okay, now we have reached here. So there is a plus. Plus has the lower precedence than the star. So we want to start popping. So we are popping star. Now division also has the higher precedence when compared to our incoming character plus. Okay, we are now scanning plus. So division, next division also has the higher precedence. So division, we are popping that division also. We are popping the star also. Okay, because star also has the higher precedence when compared to our incoming operator plus. So we have popped this all for operation and we have just added this into our output expression. Now we are checking this plus with this plus. So both have the same precedence. So we want to add or we want to push this plus into our stack. Okay, now there is an operand came n, then there is a operator came star. So star has the higher precedence, so we want to push it. N is another operand we want to add into our expression, and subtraction is a, now we are scanning subtraction. Subtraction has a lower precedence when compared to our top of the stack star. So we want to pop the star first, and okay, we just popped star, and when we are checking with another next top of the stack, plus and subtraction have the same precedence. So we want to push the subtraction into our stack. So we are pushing subtraction into our stack. Now there is L came, L is an operand. Now there is another operator came plus, plus is also with the same precedence with our subtraction. Now there is another operand came, we are just adding into our output expression. Now this is end of our scanning. After when we are reached the end of the expression, end of the input expression, we are just looking back to our stack. If stack contains operators, we are popping all the operator into our expression. Plus, subtraction, plus, plus. Okay, now the stack is empty. Now this is not our prefix expression. We want to reverse this output. We want to reverse this output. That is our actual output. Clear? So after all scanning, our output is like this. Okay, we have got the output like this. So this is not our prefix expression. We want to reverse this output, then that is our actual prefix expression. So this is the output that we got from after scanning and doing all the things. After that we want to reverse it like this. So this is our output, plus plus minus plus KL star MN star division division star exponential OP W U V T Q. Okay, now we are going to discuss about postfix evaluation. Postfix evaluation algorithm contains 4 steps. First step is read all the symbols one by one from left to right in the given postfix expression. When we are reading the symbols, if the reading symbol is an operand, then push it onto the stack. The third step is if the reading symbol is an operator like plus, minus, star, division, etc., then perform 2 pop operation. We are popping 2 operands, that is already in the stack and store the two popped operands into different variables. Then perform reading symbol operation using operand 1 and operand 2. Then push the result back onto the stack. We are popping two topmost operands from the stack and we are performing that scanned operator with the operands, and the result we are sending back to the or pushing back to the stack. Finally, we will have only one item in the stack, that is our result after scanning all the postfix expression terms. Then we are popping that result and displaying into the result. That is the postfix evaluation algorithm. So this is an example for postfix evaluation. Our postfix expression is 562 plus star 12 for division and subtraction. This is our stack for our operands. When we are scanning from left to right, if we are scanning an operand, we are pushing that operand into our stack. So first one is 5, we are pushing that into our stack. Second symbol is 6, we are pushing that also into our stack. And the third is also an operand, we are pushing that also into our stack. The fourth one is an addition. When we are scanning an operator, we are scanning the addition operator. At that time, they are looking back to the stack and popping the two topmost operands from the stack. So we are popping 2 and also we are popping 6 and doing this operation. So the result is 8. So we have popped 2 and we have popped 6 also. So we are erasing these two elements from the stack, and now we want to add 8 as our topmost element in the stack. So 8 is the topmost element now in the stack. Now we are encountered another operator, that is multiplication. So we want to do two pop operations 8 and 5 and doing this operation. So 5 8s are 40. We are popping this 2 and we have to store 40 into our stack. Now the stack contains only one element. Now we are reached here 12. So 12 is an operand, we want to do push operation, and 4 is also an operand, we want to do another push operation. Now we have encountered a division operator. So division. So we want to do two pop operation from the stack. We are popping 4 first and we are popping 12 second, and we want to do the operation like this. We want to pop two elements like this. We want to do operation like this, not 4 divided by 12. Okay, we are doing like this. We are popping the topmost element from the first, and now in the right we are popping another, and we want to do the operation in this style. Okay, not this style. You want to remember that thing, otherwise you will get the false result. So not 4 divided by 12, that is 12 divided by 4. In this case also this is applicable. So 12 divided by 4 is 3. So we have already popped the 4 and 12 and we want to insert 3 into our stack. So 3 is here. Now we want to scan the last character, that is a subtraction. So now it is subtraction. We want to pop 3 and we want to pop 40 also, and we want to do this operation 40 minus 3, that is 37. Insert that 37 into our operand stack. We want to push 37 into our stack. Okay. So after scanning all the characters, we are looking back to our stack. Stack contains only one value, that is the value of this postfix expression. So our result is 37. This is the example for postfix evaluation. We are doing postfix evaluation with the help of stack data structure. Next, prefix evaluation. The algorithm contains 4 steps. First step is initialize a stack. We are using a stack data structure for evaluating the prefix expression. Scan the prefix expression from right to left. That is very important. We are scanning when we want to evaluate a postfix expression. We are scanning from left to right. In this particular process, we are scanning from right to left. That is the main difference between the evaluation of the postfix expression and evaluation of the prefix expression. Then If the scanned character is an operand, push it into stack. If the scanned character is an operator, push operands from the stack depending upon the type of the operator. Okay. Then perform the operation and push the result back into the stack. We are popping the topmost operand from the stack and we are doing the operation, then push back the result into our stack. Repeat this step 2 until the characters or the prefix expressions all are scanned. Then we are exiting from the algorithm. Now I am going to explain an example. Our expression is plus minus star 2 2 division 16 8 and 5. So there should be a stack. We are initializing a stack, and the stack we want to scan from right to left. That is the important step. So we are starting from here. So first is an operand. We are pushing that operand into our stack. Next is an operand. We are pushing that into our stack. Next is an operand. We are pushing that also into our stack. Now there is a division operator. So division operator encounters. At that time we are popping 16 and we are popping 8 and we are doing division. We are popping 16 and we are writing here, then we are popping 8 and right here, then doing the division operator. The answer is 2. Now we want to this 2 into our stack. So now the topmost element is 2. Now again we have reached here. So we are pushing 2. Again we are pushing 2. Now there is a star. Star is an operator. So we want to push this 2 first, then we are pushing the next operand, then doing this operation. So the 4 is the result. So we have already popped 2 and this 2 also. Then we want to push 4 into our stack. Now the topmost element is 4. We have reached here. So this is the subtraction. So there is an operation. We want to pop the topmost element. We want to pop 4 first and then we want to pop 2. We want to do the subtraction. The result is 2. So the now topmost element is the resultant of 4 minus 2 is 2. Now there is another operation, that is addition. So we want to pop 2. Then we want to pop 5 also and doing the operation 5 plus 2, that is 7. Now we want to push the 7 into our stack. And we have reached the first symbol of this prefix expression. So this is end of our scanning. At that time we want to look back to our stack. So 7 is in the stack. Only one element should be in the stack. So that is the result of our prefix expression. Another stack application, postfix to INFIX conversion. Steps to convert postfix to INFIX. We are converting a postfix expression to an INFIX expression. First step is read the symbol from the input. That is the postfix expression from right to left. If the symbol is an operand, then push into stack. If the symbol is an operator, then pop 2 values. Pop 2 top values from the stack. This 2 top popped values are operand because we are pushing only operands to our stack. Then create a new string and put the operator between this operand and the string. When we are popping the value, first value is our operator 2 and then the top value is operator 1 and this is our operation that we are doing. This is our string. This string is we are pushed back into the stack. Then at the end only one value remain in the stack, that is our INFIX expression. Now in example 4, example to convert a postfix into INFIX expression. Our postfix expression is A, B, C star D, E, subtraction, division and plus. We are scanning from left to right. If it is an operand, we are pushing into our stack. When we are scanning, first symbol is A. A is an operand. We are pushing that into our stack. Next is also an operand. We are pushing that. And next is also an operand. So we are pushing that also into our stack. Now there is a star operator. When an operator came, we are popping the first 2 element. First top element we are writing here and second operator we are writing here. Then we are making a string like this. So only A is there at that time because we have already popped B and C. Now we want to write this B star C into our stack. We are pushing this B star C into our stack. Okay, we are writing inside a bracket. That is not necessary, but if you are doing like this, it is good for our infix expression. Now we have reached here our D. D is an operand, we are pushing. E is also an operand, we are pushing. Now there is a subtraction came. At that time we are popping E and D and making D subtraction E. So then we are adding this D subtraction E into our stack. Now there is another operator came. So we want to pop T subtraction E and also B star C and making a string like this. Okay. So now we are pushing this into our stack. So we have already popped this and this. Now our stack contain B star C division D subtraction E. Okay. That is inside one more bracket. Now we have reached the last operator, that is plus. So we only have two elements in the stack. So we want to pop this first and then the second. Then we are making like A plus. So we have popped this first. Is it B star C divided by D subtraction E? This whole string we are adding with our A. Okay. Now we want to, so we have popped this and we have popped this. Now we want to push this into our stack. Now the stack contains like A plus B star C divided by D subtraction E. The whole thing is added to our A. This is our infix expression. When after the scanning of all the symbol, when we are looking back to our stack, the stack contains only one element. That is the resultant infix expression. So our infix expression is this one. Okay, A plus B star C divided by D subtraction E. There is no need to put the bracket. When we are putting it, it is easy to understand. Okay. So that is all about our postfix to infix conversion by using our stack. So this is also a stack application. Next, postfix to prefix conversion. Algorithm for postfix to prefix conversion. Algorithm starting with initialize a string containing postfix expression. Then second, create a stack as for type string. We are creating a stack with the data type string. Then traverse from start to end, that is left to right. We are scanning from left to right and check if the current character is an operator. If the current character is an operator, we are popping the two topmost character and can concatenate them like if the scanned character is a operator. That current operator we are adding like this, or current operator plus first character is as operand 2 and the second popped character is as our operand 1. Like this we are concatenating and making a string. Current operator plus second character plus first character. Then put that string back into our stack. Else, if the current character is not an operator, that is, it is an operand. If it is an operand, push it as a string in the stack. Then after all the scanning, when we are checking the stack, only one element will be that is our prefix expression. Now we will discuss it with an example. Our postfix expression is A, B, C division, subtraction, A, D division, E subtraction and multiplication. So we are scanning from left to right. So our scanning is starting with A. A is an operand, we are pushing. B is an operand, we are pushing. C is an operand, we are pushing. Then there is a operator K, division. So at that time we are making a string like division. First popped character right like here and second is like here. Then we want to make a string like this. So we have already popped C and B. Now we want to push this division B, C into our stack. Now there is another operator K, subtraction. So we want to pop this to first popped element is here and second popped element is here, and making a string like this. Division subtraction is our operator. Now we want to push back it into our stack. After popping this slash BC and A, our stack was empty. Now we want to push this string into our stack. Now the stack contains only one element. We have here, now we want to scan A. So scan A is an operand, so we want to push into our stack. D is also an operand, we want to push into our stack. Now there is a operator division. So division K, we want to make a string like this, division D, first popped character here, second popped character here. Now we want to push back into our stack. We have already popped this and this. Now we are pushing division A, D into our stack. Now there is another operand came E. We are pushing that E into our stack. Now there is an operator came, that is subtraction. So we want to make a string like subtraction. First character here, second character here, making a string like this and push back to our stack. We are now pushing this into our stack, subtraction, division, AD. Now our last character is also an operator. Then we are making star. First popped character is like here, and second character popped character here we are putting as operand 1. So this is our last big string. So we have already popped this and this. So we are pushing this big string into our stack. Star A slash subtraction A slash BC subtraction slash ADE. Okay. So this is our prefix expression. Next, prefix to infix conversion. Algorithm to prefix infix conversion. Initialize a string containing prefix expression. We are initializing a string for storing our prefix expression, that is our input, and create a stack S of type string. We need a stack for doing the thing. So we are creating a stack, then traverse from right to left. That is, we are traversing from the last character to first character of the string, and check if the current character is an operator. Then pop the two top characters from the stack and concatenate them as a single string with a current operator. Okay, in between. Then we are pushing that string into our stack. We are popping the two topmost element. So first top value is operate 1 and second top value is operate 2. Then we are doing this operation and making a string like this, and we are push back to that into our stack. Okay. Then else it is a operand, only we are pushing into our string back, only we are pushing that string into our stack. Return the top of the stack. At the end of the scanning, this stack contain only one value, that is our infix expression. Clear? Now there is an example, prefix to infix example. So this is our prefix expression. So we are scanning from left to right. So first it is an operand, E is an operand, we are pushing that into our stack. D is also an operand, we are pushing. A is also an operand, we are pushing. Then there is an operator came, that is our division. So we are popping A, then we are popping D and making a string like this. After popping A and D, E is the only one element in our stack S. So then we are pushing this whole string into our stack, A divided by D. Okay, this is our one more element in our stack. Then there is a subtraction K, subtraction. It is also an operator. So we are pushing A divided by D and E. All elements we are, then we are popping A divided by D and A. All elements we have popped. So the stack contains nothing. Then we are making a string like this. subtraction. This is our operator. So then we are pushing this whole string into our stack. Okay. So only one element is in the stack now. Now there is an operand came C, we are pushing. Another operand came, we are pushing. Now there is an operator came division, so we are popping B. Then we are popping C and making a string like this. After popping, only one element is there, so we want to write this new string. We want to write this new string into our stack. So we are pushing B divided by C into our stack. Now there is another operand came, that is A. We are pushing that into our stack. Now there is an operator came, that is subtraction. So we are popping A, making a string like this, B divided by C. We are popping this two elements and making a string like this. So we have already popped this two elements and write back this, push back this new element into our stack. A divided by B, A subtraction B divided by C. Okay. So this is our new element in our stack. Now there is only one item to scan, that is an operator star. So we want to pop these two elements and make a string and push back that string into our stack. So we are popping A subtraction B division C, then making a string with concatenating with star and the second operator. Okay, so this is our new big string. So after popping the only two elements, stack is empty at that time. So we are pushing this to our stack. Okay, so this is our INFIX expression. Okay, so this is our INFIX expression. Next, prefix to postfix conversion. The algorithm contains 5 steps. First step is read the prefix expression in reverse order from right to left. That is very important. When we are reading, if the symbol is an operand, then push it onto the stack. Third is, if the symbol is an operator, then pop 2 operands from the stack. Pop that 2 operands and create a string by concatenating the 2 operands and the operator after them. Like this. Operand 1 plus operand 2 plus operate. And push that resultant string back to the stack. This whole string into the stack again. Repeat the above steps until the end of prefix expression. Clear? That is the prefix to postfix algorithm. We are using stack data structure for this. There is an example. Our prefix expression. Prefix expression is like this. Star, subtraction, A, division, B, C, subtraction, division, A, D, E. This is our prefix expression. Prefix expression. We want to convert it into a postfix expression. Okay, so we are scanning this prefix expression from right to left. Okay, we are scanning from right to left. So we are scanning E first. E is an operand, then we are pushing this into a stack. This is our stack. D is also an operand, so we are pushing D into stack. The next is A. A is also an operand. We are pushing A onto the stack. Okay, now there is an operator, division operator. When an operator comes, we are popping 2 operands. We are popping first operand A, then popping operand 2 A, D. So we are popped A and D. Now make a string like A operand 1, operand 2 and this operator, this scanned operator. Then this is a string. Then we are pushing this back to the stack again. A, D division. So our stack contain like this, A, D division, comma, E. Now there is another operator, subtraction, popping 2 operands from the operator stack. So we only have 2 items in the stack. So we are popping that A, D division. This is a single thing. Okay, AD division, then E. So this is operand 1, this is operand 1 and this is operand 2. We are making a string like ADE division E, then adding this operator into this position. So now this whole is another string. Then we are pushing back to our stack. We have like this. Okay, AD division E subtraction. So we are pushing that back to our stack. Now the stack contains only one element. We have already popped this to So now the stack contains this whole thing as the one element. Okay, A, D, division, E, subtraction. Another thing is another operand came. Now we are here. C came. C is an operand. So we are pushing this to our stack. Now another operand came. B. We are pushing to our stack. Now there is another operator, division. Okay. When division came, now the division is the operator. So we are popping B and C from the stack and making a string like this: operand 1, operand 2, the division, and we are pushing back to the stack. We have popped B, C already. Now B, C, division. Okay, so the stack contains two elements. Now A is an operand. We are pushing A into our stack. Now subtraction is an operator. Subtraction and operator. Now we are popping A, then popping B, C, division. This is operand 1 and this is operand 2, and we are making a string by adding this operator like this. So this is like a one string. Then push back this into our stack. Okay, we have already popped A, B, C, division. We are pushing this item into our stack. A, B, C, division, subtraction. Now there is another operator, multiplication. Only two items are there in the stack, so we are popping this two item: A, B, C, division, subtraction, A, T, division, E, subtraction. So this is our operand 1. This is our operand 2. Now we are adding this star into this string, and this whole string we are push back to our stack. So this is our postfix expression. Okay, we are pushing this into our stack. Now the stack only contains, we already popped this and we are already popped this. So the stack contains only this expression. So that is the resultant postfix expression. So that is all the applications of stack related to expression evaluation and conversion. Thank you for watching. For more videos, subscribe this channel.